Okay, we'll start back. So something was highlighted to me as we broke this before coming, that I kept talking about the assignment and the workbook, and I hadn't actually given it out to you. I hadn't put it up live on Moodle, so I've done that now. So if you have a look at the Moodle page, also I hadn't uploaded or hadn't released the notes. So I released the notes for this week that we've just covered, plus the notes for next week as well. But underneath the announcements, I now have a section called assignments, where you can see your assignment there, and then I have week 5 and week 6 there as well. If we go back up and have a look at the workbook itself. Oh, I've given you the old version as well. So let me fix the dates on it, but it's the questions should still be valid. Okay, so we have a couple of questions on this. They all kind of work from, I was slightly behind here when I was writing that one last time. So we've done variables. So it starts from variables forward. So last week we did user input. The week before that we did variables. So you are 1 week behind really, because none of these questions ask for, what do they do? The question tree asks for user input. So the first 2 questions were from 2 weeks ago, and then the next 2 questions are from last week, and then we can move forward that way. So question 1. Make a program that has 3 integers, D, H, and M, and display the number of D days, H hours, and M number of seconds in D days, H hours, and M minutes. You can assume, to begin with, that D, H, and M have the value of 1, 17, and 34. So what I'm looking for there is to work out, in a total of 1 day, 17 hours, and 34 minutes, how many total seconds are there? And so I want you to write a calculation that uses these variables, D, H, and M, plus the actual number of seconds in 1 hour, the number of seconds in 1 day, and the number of seconds in 1 minute to work out that calculation. The point of this is that if I change those values, if I go into your code and change them, or if you put in user input and you allow the user to enter in values, it should still calculate the correct number of seconds for however many they have. So if they enter in 2 days, 5 hours, and 59 minutes, it should give me the correct amount of seconds in that time period. Question 2, create a program to swap variables X and Y. A classic computer programming problem. Variables generally mean that you can only store information in there, and it's one of the things we have to deal with is actually swapping the information in and out. So you have to figure out how to do that. The hint I'll give you on this is you are not restricted to only having 2 variables. If you feel you need more variables, you can use more variables. But again, imagine if user input is going to be involved. Okay? Imagine if you don't know what those numbers are. If you don't know what the numbers are, you have to have a sound way, an algorithmically sound way of processing it to make sure that we do, at the end of it, the value that's inside X was the original value that we have inside Y, and the value that's inside Y was the original value inside X. Okay? And try it with multiple combinations of numbers. But very often I get someone who will put like either 10 and 20 or 1 and 2 and swap them. And there are versions I've seen on the internet where it works for those numbers, but it doesn't work for all numbers. And what I'm looking for is something that is, again, it's algorithmic sound. If you don't know what the numbers are, it has to work for every possible combination of numbers. Question 3, create a program that takes in an integer from the user. So an integer is going to be a whole number, and outputs just the last digit of that value. So if they enter in 123, you print out 3. It's the last digit in the unit digit in whatever they enter in. And we've looked at ways of splitting up numbers using some of our arithmetic commands to deal with that. Create a program that takes in 5 integer values. So that's 5 separate values. That's not one value with 5 digits. It's 5 individual inputs, and prints them out in reverse order. It is as simple as it sounds. Okay? If you're working out how to take in a 5-digit number and split it up and print it out in reverse order, you are overcomplicating it completely. I want you to have 5 variables, 5 user inputs. If you take them in A, B, C, D, E, you print them out E, D, C, B, A. Very, very simple. Okay, the stuff that will be not really achievable until we finished this class. Make a program that enters a month number and it prints out the name of the month. If they enter in a number that's not a month number, in other words, minus 12 or 45, let them know, hey, this isn't a valid month. And not the last question, the second last question here, which will be, we're going to do two or three questions now before we finish up tonight, and one of them will help you build this. This is where this type of question where you absolutely would need logic gates connecting things. But you're going to take in a day, a month, and a year value, and you're going to work out, is that actually a valid date? Okay. So what we're going to do here is we're going to analyze what months of the year have what number of days in them. So, for example, if you entered in the 31st of September 2001, it will come back as false. There are not 31 days in September. But if you entered in the 29th of February 2012, it will come back as true. 2012 is a leap year. In a leap year, February is an extra day, which would be the 29th day. So you're looking for those type of values. And then the very last question, which you wouldn't be able to do until after next week's labs, is a guessing game question. Take It's a guessing game question. We're going to generate a number between 1 and 100. And then we're going to ask the user to make a guess. And we will keep asking the user to make a guess until one of these conditions are matched. Either they guess the number correctly, or they make 20 incorrect guesses, or they enter in a negative number, so they want to quit the game. In addition to that, the program should, when it ends, it should tell them how many guesses the user has made. So you got the number right in 5 guesses. You did not get the number right. You used all 20 guesses, something like that. And each time the user guesses incorrectly, it should tell them whether it's too high or too low. In other words, give them a little bit of a guide to be able to narrow down the number. If you only have 100 possible outcomes and you've 20 guesses, and it's going to tell you higher or lower, it's a pretty easy game for the player, but it will allow you to. This is a pretty complicated game. If you can build this before the 19th of November and get it working the way you want it, you should be pretty proud of yourself, because then you have used all of those 5 useful elements of our project, or of our journey in programming. We have output. We tell the user, we give them feedback. We have input. We're going to take in the guesses from the user. We have variables. We're going to store that guess, and we're going to store the number that we have to guess, so that we can get it generated, or we can evaluate it. That evaluation, the if statement, does the number they entered in match the number that we have, we're looking at the moment. And next week, if they get it wrong, we're going to say, well, let's ask them again. And let's keep asking them again until one of these 3 things happen. Okay? So while you are technically 2 weeks late, although I'm trying to remember. No, I only issued it last week to the first week. So you're 1 week late in getting the worksheet. You should be able to do, by the end of today's class, you would have at least we would have covered all the technical elements to be able to do the first 6 of the 7 questions on it. And there's a month remaining. Now, I'm not saying that I'm expecting all of you to come back in next week and go, yeah, got 6 of them done, only need to worry about the 7th one. But you definitely should be able to start chipping away. The first couple of questions are quite manageable. I think, if you go back and look at our source code, we may have done very similar examples, which might give you kind of a bit of a head start. Okay, so I'm going to do 2 questions. I'm going to do a question that's going to ask the user to enter in a day of the week, a number for the day of the week, and we will print out the appropriate day. And then I'm going to do a question where we're going to get the user to enter in 3 exam grades, and depending on what their grades are, we'll tell them whether they've passed by compensation, or whether they have failed. And I'll go through that more once we've done the first one. So, get rid of that. Oh, good. That's updated. Super. Let's have a look. So we're going to go File, Save As. Okay, so we're going to start off with that basic skeleton of code, and we're going to build this out to be a program where we're going to say, please enter in a number, or please enter it. for the week. And it'll tell us whether that is Monday or Tuesday or Wednesday or whichever day it may be. Okay? So in this scenario, we're going to have one if statement. We're going to have multiple else if statements. And then for any number that is outside the range of the days of the week, so if it's not 1 through 7, we will have our else statement, which will say that's not a valid number. Does everybody understand the question that I want to do? Not necessarily how we do it, but what I actually want to achieve. We're going to enter in a number, and it's going to tell us, yes, 3. Well, 3 relates to Wednesday or Tuesday, depending on when we start the week. And if they enter in 75, we're going to come back and go, there isn't a 75th day in the week. So that's not a valid weekday number. For today's question, I'm going to assume that Monday is the first day in the week. So Monday will be 1, Tuesday will be 2, and so on. So if x is equal to 1, well, then we're going to print out Monday. Spell it correctly. Okay, so that's our first option. Now, if we left it like that, it would only give us an output if we entered in the number 1. If we enter in any other number, it just would finish the program. There's no output to it. So we obviously need to add in some extra outputs. So then we're going to have an else if. And because we're using else if, here we need to put in a second condition or another condition. So we're going to say if x is equal to 2. We're going to logically extend this out. And here we're going to have system.out.print. And here we're going to print out Tuesday. And you can kind of see where this is going to go. So I'm going to quickly finish this off and I'll go back and talk through it. Wednesday, Thursday, Friday, Saturday, Sunday. Back up here, Tuesday, and this is going to become if it's equal to 3. And then that becomes Tuesday. And if it's equal to 4, it becomes Thursday. And it's equal to 5, Friday.
Sorry, when you type into replace a word and highlights the rest of the green, is there a way that, or is there a shortcut to actually change all the holes that are highlighted, or is it just
Not in Notepad++, no. So the reason why it's doing that, so for example, if I click on else here, it'll highlight everywhere else that else does it. It's just something built into Notepad++ to say, hey, you might be, if we're looking for a variable, here's all the other places that word's used, or all the other places that variable is used. There are development environments which allow you to do something called refactoring. And refactoring is where you might say, do you know what, that's a really poor name for that variable. I want to change it, but it's used 75 times in this program. I don't really want to go through it 75 times. So in that, actually, does it let me do it here? No. Actually, if I try on this. Okay. So you can do a really lazy way of doing it, or not a lazy way, a blunt way of doing it, which is find and replace. We get sick of kind of going, yes, change that one, so we just kind of go replace all. And then if it's just a one letter, it'll mess up a lot of commands later on. Whereas a refactoring command, so something like Eclipse or NetBeans or Visual Studio Code has this stuff built in. You can right click at it and you're basically saying, this is my variable. I'm going to change the name of this variable. So everywhere where this variable is used, update it to be from X to user input or whatever we want. For this, because it's quite a bare bones piece of software, we don't have that. It just is going to encourage you to have sensible variable names. And also not to do what I do and copy and paste. Because we will see if I've got this correct. And if I haven't, it'll highlight the errors we can have. Every time you copy and paste, and the idea is that, oh, I'll copy and paste and I'll change it. And then I'll copy and paste again, and I'll change it again. That's one more opportunity to miss. And if you did what I did, where I go 1, 2, 3, 4, 5, 6, 7, and then go back into the top and start editing them, it's always, nearly all, it'll be quite rare now if I don't have an issue with this. So Java C conditionals. Okay, it's quite rare. And then we've got Java C, and then conditionals again. 3. Okay, so now it's going to ask me enter a number for the day of the week. And so if I enter in 3, it tells me it's Wednesday. If I enter in 5, it tells me it's Friday. If I enter in 9, well, it doesn't tell me anything yet. So let's go back into our code and have a look. So what we've done in our code, and I'll zoom it out a little bit for the moment, is we can see we have enumerated through several of our options. We check to see if it's 1 or 2 or 3 or 4 or 5 or 6 or 7. But when we get to the end of that, we don't have everything else. And again, let's think about our integer value. Our integer value has a maximum capacity of 4.8 billion possible numbers. And we have picked 7 of them. So there's a very high chance that the user will enter something in wrong. So to allow for that, we can do an else comment here. That will say system.out.println, and there's something like invalid entry. And now this will deal with the remaining 4 billion possible options that they might enter in. So if I save this now, compile and run. Now if I enter in, let's say, minus 45 as a day of the week, doesn't exist. If I enter in that one, it doesn't exist, okay? But it gives me a response. That's not a valid entry, okay? And that is a way of enumerating true. So again, when we think about our problem, when we think about what we want to do with our problem, you have 2 things to think about. The first thing is, what do you actually need to act upon? And ideally in your programming, you want to act upon the least amount of options. So if I have to build a piece of functionality, I only want to build that functionality for where I have those options. So if I've got 7 days in the week, or 12 months in the year, or 5 items on my menu, I only want to have specific actions for those elements. Okay? And then for everything else, because we're dealing with a large data type, and there's a lot of numbers inside it, I want to say, oh, well, everything else falls into this category, which for us is just going to be the invalid entry. To say, well, look, if it's any other number bar the 7 really specific numbers I've picked, I don't care about it, move on to somewhere else. Okay? We will get to a point where it'll say invalid entry, and then it'll go back up and it'll say, please enter in a number for the day of the week. And you can enter it in, and it keeps doing that until you enter in a correct number. But let's look at the structure of that code. I'll get it all in here. Yeah, most of it. Okay, so I have my if statement up at the top, and I check for an option there. So I have 1 if statement, and that's at the very, very top. I have 6 other enumerated options. Okay, so I have 6 other values, 6 other things I'm checking for. And they go else if, else if, else if, else if, all after each other. At the very bottom, I have an else statement. And my else statement then is for anything else. If they don't enter one of those 7 prior options that I've mentioned, we are going to run the else option. In any one of these options, so I have 8 possible options there, it'll start at the top and it'll work its way down. So it takes your user input. Is your user input equal to 1? No, okay. Is it equal to 2? No, okay. Is it equal to 3? No, and it keeps working its way down. As soon as it finds one that matches, it'll run whatever's inside this line block of code here, which happens to be just one printout statement, and it'll skip everything else below. And in my program, we'll jump down to line 34 to continue the rest of the program if there was anything there to be done. In my program, there is nothing else to be done. That's the closing bracket for our system.main, or for our public static void main, and that's the closing bracket for our class. So that's the last action inside my program. But it is very possible that you will have subsequent follow-up actions after the if statement finishes, and it'll just continue down to them. But it starts at the top, it checks all of the possible options. If it doesn't find any that match, it'll run the else option if one exists. If it does find one that matches, even if it's midway through or at the very top, it'll skip everything else below. It won't bother evaluating it. You know the expression, when someone loses something, oh, of course, they were in the last place I was looking for them. Well, that's logical sense. If you lose your glasses, your phone, your keys, you search several places and you find them. When you find your keys, you stop looking. You don't keep looking for another hour and a half. And it's the same thing here. When we find one of these options that match, we don't need to check all of the other ones. Because we found one that matches, that's matched our criteria, we have answered our question, so we can jump to the next part of our program. Does that make sense? Does anybody have any questions on that code? Okay, I would like you to do 2 questions, and I'll put them up here, and then I'll go through them myself. So, question 1 is going to be create a program. Word wrap. Question 2. Okay. 2 numbers. Like this. Okay, so 2 questions there. They're both quite similar to each other, but I'd suggest doing question 1 first and then have a look at question 2. So question 1 says, create a program that takes in 2 numbers and outputs which number is smaller. So you have to have a question to see, is A smaller than B or is B smaller than A? And the second question, create a program that takes in 1 number and it tells the user whether that number is odd or whether it's even. Okay, so I'll give you about 10 minutes to have an attempt at those, and then we'll go through a solution.
Should I ask somebody about
I will highlight. Okay. Yeah. You don't need to use your directly use the only thing you use your question, right? If you want to use your great. But what I'm saying is when you're designing a program, assume that at some point the user will be entering it, so you won't know what the values are. Okay, because I've seen students fake the outputs by switching around, or if they program with it, hard coding because they know the answer. Oh, here, that's not really useful. Okay? So a good way of making sure you're doing it right is make it have user input, and then as a result, you'll be able to verify it's working correctly. Yep. Oh, okay, right, okay, yeah, I'll get that set up. Yeah, no problem, I'll get that set up.
Just went off, I didn't let you in. Went off later on, I didn't let you
Especially when it doesn't break your work.
One second, sorry.
Sorry, guys, sorry. I can't listen to the professor because you two are talking, and now you're acting like you're the only two people. We're not 12, you know. Please be quiet. Sorry? Thanks.
Oh, it brings back our reason.
Yeah.
Okay.
Sorry about that. Right, okay, move this turn off. So let's have a look at what we're going to do here. Question one, we're going to take in two numbers, and we're going to output the smaller number. So let's create a new Java file, copy all of this, call this conditionals 4. Copy that, save, conditional 4.java. And I'm going to delete all of the if statements because I don't need them just yet. And I'm going to take in, I need to declare another variable here. So I'm going to have int x, and I'm also going to have int y, which is going to be my second number. And if I've asked, sure, first. Enter second number, and that'll be 4y. Okay, so here's what we have so far. Now, obviously, there's no if statements, there's no question been asked here, but this will create two variables, an x and a y variable, and it'll prompt the user to enter in a value for x and for y. And then once we have that, we can create our if statement. So let's do that and say if x is larger than y, then we're going to say that system.out.print. We're going to say x is the larger number. And then we can have an else option here. Where we say y is the larger number. And again, this code's going to get thrown up onto OneDrive, so don't be too worried about taking it all down. But there's our evaluation there is if x is greater than y, well, then we're going to say that x is a larger number. Otherwise, we're going to say y is a larger number. So let's save this right into my code here. Screen, Java C, conditionals 4 of Java. Great, I'll OK, and then Java conditionals 4. Class, run that, enter the first number, I enter in 23, enter the second number, I'm going to enter in 45. 45 is the larger number. Okay, super. Now, if I do it the other end, if I enter in 99 here, and enter in 1 here, 99 is a larger number. Now, there's one criteria we haven't looked at, which is, what if the numbers are the same? If I enter in 1 and 1, it says 1 is the larger number. So it gives us the right value, but the statement is wrong because it's not larger. They're both the same. So what we're going to do is we're going to go back and we're going to edit our code a little bit more. We're going back over here. This is going to go from an else to an else if, and we're going to say if y is bigger than x, but that's the only change we need to do there. Okay, so I've added in after the word else, I've added in if y is greater than x, but the output remains the same. And the last one then is if they're both the same, I'm going to print out both numbers are equal. So now, if I go back and I compile that again, and I run that, I enter in 1 and 1, it tells me that both numbers are equal. Okay, so that's the first question. Second question was, create a program that takes in one number and tells the user whether it's odd or even or odd. So let's go back and get a piece of code to do this. File, save as. Let's go to condition 5. I'm going to put all these in the OneDrive now once this class is finished. 5. We only need one number. Don't need this bit of code here. Don't need go there. Say enter number. And we can get rid of our if statements there for a moment. Okay, so we have our code that's going to prompt the user, please enter a number. They're going to enter in a number. How do we discern whether it's even or odd? Any thoughts?
If the remainder is 2, it's even.
If the remainder is 2, it's even, okay. So we're going to divide it by 2. Yeah, we're going to divide it by 2, but the key word here is the remainder. We're going to look to see what the remainder is. So we're going to use our modulus command. So we're going to say if x modulus, and the only thing wrong with the statement we said there, if the remainder is 2, is that if the remainder was 2, that would be counted as one more even division, because you're dividing it by 2. So the remainder actually would become either 0 or 1. Remember, when you're using the modulus command, and you're dividing by, let's say, 2, it will be up to but not including the number. So it will be 0 and 1, but it won't include 2. If we're dividing by 3, it will be 0, 1, 2, but not include 3. So we're checking to see, is that equal to 0? And if that is equal to 0, then we're going to say system out dot println. We're just going to be very simple here. I'm going to go even. Put a semicolon here. Otherwise, well, if it's not even, it must be odd. Save that. Going through here. No, I'm not using the right command. That's fine. C file. That's okay. And then conditions. Enter a number. If we enter in 23, that's an odd number. Super. If we enter in 44, that's an even number. If we enter in minus 88, that's also an even number. Okay, so it's working by dividing it by 2 and seeing what the remainder is. If the remainder is 0, it means it is gone. 2 has been divided into it, and nothing's left over. That's ideal. And we get even. Otherwise, if we have 1 left over, it means it's an odd number. Now, the last thing we're going to do before we finish up is we are going to use a logical connector with our values. So we've done several little examples today. And one of the ones we have done is to check to see if a number is odd or if it's even. And another one we've done is to check to see if the number is positive or is it negative. So what we're going to do is we're going to write a piece of code now to check to see if a number is odd and positive or even and negative. And once we can do that, we can go through all the possible combinations of the numbers. So, file, save as. Before I go and start this example, does anybody have any questions so far? Does this seem to make a bit of sense? I think what we might do is, actually, do you know what? Let's leave it here now. And if you need to head off, you can head off. If you want to make a start on the worksheet, you can make a start on the worksheet. And we'll resume this next week, where we'll start these two. We'll do this question, if it's odd and even, or if it's positive and even, or odd and negative. We'll do that next week, and then we'll start into the loops, and we'll give more time to the worksheet questions. You have a bit of work time on that. Okay? So stop the stream.